All right, so we're coming back to day 2. Again, I'm going to do my best to kind of go over everything with you. Make sure you're all good. Okay, same thing. You're going to need your wonderful, your fantastic, your calculator right around available to you. Remember, when you're doing this, you want to press second and 0. Make sure, as we go all the way down, that your diagnostic is on. Again, if you're doing an online calculator or a physical one right there, you're fine. And remember, this is not on yet. Now it is. Anyways, we're going to go ahead and look at this problem. It says use your calculator and the table of data below to find to complete the following. So we've got months, we got temperatures, electricity bills. Okay, so what we got here is X and Y values. X and Y values. Same thing as before, right? So scatter plot of the pattern looks like a graph of A. Let's figure it out. So to do that, we're going to go ahead and go on stat. We're going to edit our list. Now, I've already put mine in just to save time because I have to go pretty quick. Remember, you can pause whenever you want. So I went 61, 58, whatever. And then the same thing with this one, 150, 139. Made sure they're all matched. You should see that they all match. We're going to go ahead and click on zoom. And we're going to go to zoom stat. Okay. All right. So we look at this, and again, we can kind of tell, oh, where are we going? We're going linear here. Remember, there's 4 different options: quadratic, cubic, exponential, and linear. So what we're dealing with mainly is linear functions. Okay, so we're going to go ahead and write linear. Okay, and it says function, round all parts to the 1,000th. Okay, so we're going to go ahead and go stat, calc. We're going to go on a linear regression. Now, before we did the whole store the regression equation, whatever, we don't necessarily need to do that. We just want the function. That's only if you want to graph it. So we're going to go all the way down to calculate, and we are going to calculate it. And there we go. It tells you everything you need. Nothing special. So nearest thousands, we're going to go y equals 4.148 x plus negative 117.676. Now I probably should have written it as this. That is definitely the more correct way of doing it, but that's my first time looking at the problem. Okay, that's golden. That's fantastic. Now, the line right here just tells you how good. Remember, the closer you are to 1, the better. Of how close your points are to that line of regression. We don't have to graph the line of regression, but what we got here is some interesting stuff. Okay, so we're gonna look at all these. We're gonna determine the following are strong/weak linear associations. Okay, so what you want to do is you're basically going to be drawing the line. Let me get some color that's a little brighter. So it's easiest to see in this one. So basically, you want to think about drawing your own line. And the goal is when you draw your own line, this is just a visual for you to see how close the points are as you draw it. You kind of want the same amount of points on the line, above the line, and below the line. So this one right here is a strong linear I should put positive. Strong linear positive association. Okay, so strong linear positive association or regression, doesn't really matter. If we look to the right of it, this is not linear, right? This is, we would just say like not linear function, no association. Okay. Now, sometimes they can go down. So again, you just kind of want to have, this is just a line for myself just to kind of see it. I can see it's negative now. I can see it's still pretty strong. There's still some points on the line. They're pretty close. Some are a little farther. So I'm actually going to go with strong on this one too. The points are pretty close. So a strong linear negative association. Okay, wonderful, fantastic even. Next up here, not so much. There's no way I can write a line. It's like there's no pattern, if you can tell. Like, it's just all over the place. It's just jumbling around. Here we do have a pattern. So this one I'm just going to say not a linear association. Okay. This is all over the place. I cannot draw a line. All right. So let's go ahead and do this one. Twin Pixie, a large supermarket chain conducts, again, if I'm going too fast, just pause it. I'm just trying to save memory on my phone. A large supermarket chain conducts market analysis on its store brands of breakfast cereal. The chain sets various prices for its 15-ounce boxes at its different stores over time. Then, using this data, the Twin Pixies researchers predict the weekly sales of the entire chain of stores for each price to obtain the data. Okay, so we have price per box, demand. Again, X, Y. Okay, let's go ahead and put this in our graph. So we're going to go ahead. We already have our diagnostic on, which is really nice. We already have it on, so we're just going to go. I'm going to clear my list. So I just go down to 4, and then I press second stat. Clear list. Again, stat. Clear list. Second stat. Clear list. You can also, whoopsies. You can also just delete them in that thing. This is just a little faster for me. Well, I guess it's not as fast as I thought. Okay. Now we're gonna go stat, and we're gonna just go edit. And again, if you wanted, you can do the other one, and you can just delete it right here with the delete button by hand. So we go 2.4, 2.6, 2.8, 3, 3.2, 3.4, 3.6. And then right here, we're going to go 38,320, 33,710, 28,280, 26,550, 25,530, 22,170, and 18,260. And again, a good indicator I did it right is that they all match. There's no extra and there's not a less. Okay, so we're going to go on Zoom, and we're going to go on Zoom Stat now. And the plot should already be on from before. So here we go. And that looks pretty linear to me. And it looks like a pretty good regression line. Like the R value is going to be pretty high on that one. So we're going to go ahead. It represents a linear function. We're going to make the equation round to the nearest 1,000. So we're going to go stat, calc, linear regression. Where should be there. I know I'm going to need this later for the predict the demand per box if it was $2, $4. So what I'm going to do is I'm going to just hit head of the game and function. Okay. And we're going to go ahead and calculate. So we're going to go just write our things down. So we got y equals negative 15,358. 0.929x plus 73,622.5. correlation description from what we saw and what you can see. We can go back to graph. Beautiful line. It is a strong, positive, I don't know, linear. So, okay. Describe the nature of the association between the price per box and demand. This one we can just kind of look at it. And we can see the lower the price of the box, the higher demand. So that's what we're going to write. Well, I guess I probably should say it here. The lower price, oh my God, what am I doing? Price boxes have higher demand. Okay, you can write something more eloquent. Again, I'm running out of time. Predict the demand if the box per price is $2 and then $4. So again, our $2, $4, that's our X value. So we're going to go on to here. We're going to go second trace value 2. Oops. Second trace value. Second trace value 4 should work. Is he gonna make me do it by hand? Ugh, we can do it by hand, I guess. It's a little annoying. Did I forget something? All right, we're gonna do it by hand. That sucks, but it is what it is. So all we gotta do for doing it by hand, I'm not really sure why that's not working. So we go f of x of 2 equals negative 15,358.929 times 2 plus 73,622.5. All right, so we're gonna go ahead and do that. We're gonna type it in exactly how we see it. Okay, so it would be 42,904.642. Okay, and then we're gonna do the same thing here. We're gonna go f of 4 equals negative 15,358.929 times 4 plus 73,622.5 equals, and again, I'm just going to type that in. So we're going to go negative 15,358.929 times 4 plus 73,622.5. 12,186.784. Like I said, sorry if this is a little slow. I appreciate you guys. I mean, they're not a little slow, a little fast. Appreciate you all being here and dealing with this while I'm dealing with what I'm dealing with. Hopefully this makes sense. Go ahead, work on your new worksheet. You're going to do amazing.